Let me record here. Graphing, and we will not be doing these by hand. We're going to strictly rely on the calculator. Graphing polynomials. So tell me, because we talked about it when we factored polynomials, what is a polynomial? Anybody at all? More than one x term, yes. So it's something like 6x to the 4th plus 3x to the 3rd minus 8x squared plus 2. Okay. The only restriction here, or the only qualification, is that the exponents on x have to be positive whole numbers. Okay? Positive whole numbers. So if you see exponents on x, now it doesn't matter about the numbers in front, the coefficients, they can be whatever. It's only the exponents and, it's only the exponents attached to the x. Make sure when you write it that the exponents are in descending order. They start from the biggest and they work their way down to the smallest. So descending order.
We don't need any placeholders?
No, not now. You won't need them.
Even if they're not in descending order?
You want to put them in descending order because that's standard form.
Okay.
But you don't need placeholders here. That's only when we're dividing, really, that we need them. So a couple of vocabulary terms with this. This number that sits on the end, what is that called?
Constant.
Up close. Constant. Good job, Drew. Constant. Now, once I have it in descending order from biggest to smallest exponent, this number in the front is pretty special. Do you know what that's called?
Leading coefficient.
The leading coefficient. Ben, will you grab that, please? One other pretty important piece on here, and that is when it's in standard form, it's this first exponent, the biggest exponent. Do you know what's wrong?
I was getting a razor from Demaio.
Did you find one?
Yeah.
You have one? Oh. Okay. Do you know what this exponent's called? The biggest exponent? Your largest exponent, yes. No. It's actually called the degree of the polynomial. Okay. The degree. So the degree is pretty important because we classify polynomials by their degree. We give them a name. Okay. So I'm going to give you a little chart here. Have y'all got that? Can I go forward? All right. Based on the degree, remembering the degree is the biggest exponent. All right. So let's start with 0. We'll take it up through 4. If you have a degree of 0, so think about this. Your biggest exponent on x is 0, and anything...
Wait. So we've got b. Just an x, or that not even b in there?
So it's like ax to the 0 power. How does that work? Anything to the 0 power is what?
0.
1, right? 1. So essentially this is just y equals a. So y equals a number, right? So that's just a constant. Does that make sense to you?
Yeah, it's just like it's not even there.
So, well, it is, but it's like y equals 2 or y equals 3 or y equals 4. That has a degree of 0. So what it looks like when you graph it, I had to make my pen a little skinnier, is in the form y equals, that's a horizontal line. Yes, no, maybe so. Correct. So it's just, but I wanted you to see why we say it's a degree of 0. All right, let's take it up one. If you have a degree of 1, so now I'm talking about ax 1 plus bx 0.
You just have X.
And I don't really even need that x 0 there anymore. So what is that?
That's your,
What does that look? It should look like something to you.
It looks like
The
ax
equation of
plus
something.
B equals 0.
It looks like what, Ben? Say it again.
Ax plus b.
Okay, I thought you said something
minus
else.
C or something
Mx plus b. Absolutely. It looks like the equation of a, which is a
like that. Right.
line. Somebody said it, a line. This is a linear function. Okay? So a line, remember, can look like this if it has a positive slope. If that a in front, remember those a's when we were graphing quadratics? If it was positive, it opened up, negative opened down. So if it's the a in front, whenever I'm talking about a linear equation is positive, it's going up. Or it could be negative and go down. So that's what the graph would look like. Does that make sense to everybody?
oh, I get it.
So the 6 would be different
The what?
from, it's like 4.
Yes, the 4's going to be different. We're going to get to it, no worries. How about 2? So now I'm talking about I didn't mean to do that. ax squared plus bx plus c,
That's your exponential.
close, what's it called? What is that? A what? A parabola. Also known as a, starts with a Q, quadratic. Good job. This is a quadratic. When we graph it, it looks like a parabola. It could open up, it could open down. Remember, we're going to take this up to 4, so let's do 3. You probably don't know this one. A squiggly line, yes. It is a bit squiggly. Plus cx plus d. This is called a cubic, which makes sense because when we raise something to a third power, we call it a cube, right? So this is called a cubic, and what it does, it looks kind of like this, or like this. It can be stretched out, stretched in, sideways, or stretched sideways also, but in general, that's our general form.
So does the leading coefficient determine if it's the
Up or down? Absolutely. That's what it, every single time, in every single polynomial. Good job. Not always. The parent function, just x cubed, would be kind of, but no, it's not. No, they don't share the same properties of parabolas.
This one gives you.
Yes, Ben?
So whenever we're like, it's giving us a question, so we just have to look at like the biggest like number to see what the biggest exponent is.
Yes.
Alright.
Yes.
So we need to know how to graph all these different things.
On your calculator. We're not graphing them by
Graph the
hand.
same,
No, they
Will
don't
there
look
be
anything the
bigger
same.
than 4?
No, you may have some bigger than 4 that you have to graph, but as far anything past 4, we generally just call it like if it was 7, a 7th degree polynomial. Anything bigger than 4, you can just do that for. All right, quartic, which is 4. My biggest exponent then is 4. So, do you see what's happening here?
You're saying another degree shot.
Exactly. Every exponent, every time I go up, I'm kind of adding another hump there, okay? Now, some of these humps are not as pronounced as what they are in the parent function that I'm giving you, and that's okay. Yeah.
What's above the C?
Squared. Sorry. Not the formulas, just be able to recognize and classify them by their type. So on your homework tonight, you'll have, is it a polynomial, yes or no, and why? you'll have classify it by its type, state the degree and the constant, and then you'll have to graph it. Okay, so let's talk about graphing them.
Wait, so these are pollen.
Yeah. All right, you need your calculator.
Can I use like an apple on phone, just like, you know how I do it? Like a calculator on
Is
it?
there a sign?
Okay, so remember Friday on your test, you can't use an app on your
I'm
phone.
about to get one.
Okay.
Is there a website?
What's that thing called? What's this TI?
Just trying to learn how to do it.
There, if you have an Android, you can download Wabbit Emu. WABBITEMU. It's an emulator. But I don't know about iPhones. What?
GameCube emulators.
I do not know what you're talking about.
Super Smash Bros.
Okay, let's graph.
What do I do if I don't have?
Follow along.
Oh, Dad, I bet you guys wish your iPhone could do this.
If you don't have a calculator, you might want to look on with somebody because when we start adjusting the window, it gets hard. There is a website, a graphing website. It's called Desmos.com. Is that what you're on? But the struggle with students is the getting it to graph correctly in the window that you're in. So make sure you can adjust that for your test. All right, so here we go. Tell me, yes or no, is it a polynomial?
Yes.
Why?
Because it's more than one x.
Okay, why else?
There's all the x's from
All the exponents are positive whole numbers, right? No fractions, no decimals, no. Now, the coefficients can be those kind of numbers, but as long as the exponents are positive whole numbers, we're good, all right? What is the constant?
7.
7. What is the leading coefficient?
5.
What is the type?
Cubic.
Cubic. Let me see how much you remember from when we graphed quadratics. What is the y-intercept? 7. Very good. The constant and the y-intercept should be the same thing because remember, the y-intercept occurs where all the x's are 0. So if I plug in a 0 for all the x's, what am I left with? The 7. So that's the y-intercept. That's where it crosses the y-axis.
Wait, hold on. I'm trying to get this talking.
All right, let's graph it. So on your calculator, you want to go to y equals. Okay. If you get lost on my key history, you can look there on the right. Those are the exact buttons that I've pushed. Okay. So y equals, I cleared out what was there. I'm going to do 5x to the third. 5x, raise it to the third. That pulls up, that's your variable symbol. You have one too, it's just in a different place than I am. I'm a Casio. Casio is actually easier to calculate our critical points tomorrow, but. Plus 3x squared minus x plus 7.
Wait, hold on. My x went like.
When we were graphing before, we always started out on a standard window, a 10 by 10, right? So hit zoom 6.
Wait.
That one doesn't have one. Okay.
Wait.
Zoom 6. Standard 10 by 10. And here is why. I want us to play around with adjusting this window so that we can see. If you look, all the good stuff is happening right here, right?
Oh, it's one of those things you can.
Yes, it's a cubic, absolutely.
I got it. I grabbed
So there's no way for me to do that.
Your window will in just a second. Yours, it does. It does. Let me show you. It's going to be that you can adjust this window to get a good picture. Okay? So if you look, understand, this is the x-axis, right? From negative 10 to 10, and the y-axis is going from negative 10 to 10. I want to see more of this part bigger, then I do all the rest of it. So I think I'm gonna cut my window off. And let me see if I can do this where I can, I think what I'm gonna do is kind of zoom in and have a window about like this. Does that make sense? Do you see why I would want to just see that part? Okay. And some of them, your humps and things aren't even going to show up in your 10 by 10 window. You're going to have to start adjusting.
Wait, so can
All
I
right.
just do this?
So here's what I want to do. This is the hard part, guys. Y'all stay with me. Hit the button that says window. Okay. It's giving you your X minimum. So how far left do you want to go? It's giving you your X maximum. How far right do you want to go? The scale just tells you how often you want a tick mark. If you've got 1 there, it's going to give you a tick mark every 1 unit.
We want to go up.
The Y min, how far down do you want to go? And the Y max, how far up do you want to go? Again, with the scale, how many times do you want a tick mark? Okay. So left to right, if I look back at that graph, left to right, what do you think a good range of X would be?
-3.
Absolutely.
Times positive 2, 3 or something.
I agree. I agree, Banks. I think -3 to probably 3 is a good window there. Okay. So now if you hit graph, what I've done is I've shaved off the ends of those X's that I didn't need.
So it makes it look like more zoom.
I'm zooming in on it so I can see exactly what the graph is doing. Now I want to cut some of those Y's off. I don't need all those Y's. I'm seeing too much. So I'm thinking, what do you think a good Y?
Negative. No, actually 0.
Maybe 0, maybe 0 up to 10.
That's not solid.
Okay, let's try it. Smallest Y, maybe 0 up to 10, and let's hit graph. Much better picture. What do you mean it just turned to X? Get a little bit more. I think I'm going to adjust it to from 5 to 10.
That's what I'm saying.
I think that's an even better picture. I could even cut off a little bit more of my X's if I want and take it maybe from -2 to 2. I think that might be what you said at first too, Banks.
Where do we put 5?
Now I've got a wonderful picture. Do you see that? So, on your homework, what you'll be doing is you'll be adjusting these windows until you get to where you can see what you think is the good part of the graph. Then you're going to sketch it for me and you're going to tell me what window you used. So for this one, I would say, okay, my sketch of this graph is going to look like, you don't have to be exact or precise. I just want to make sure you're graphing the right thing. My window here, yes, Ben?
So I have it like set up like it's supposed to be. And how do I make it actually work? Like, what-
I don't have a calculator. I'm
Me either.
2 to 2.
Matt, you can just use the app. You can't use
Basically,
Zoom,
I was
but
just
it's
had
better than Apple.
Your Y's now. Your Y's. By the way, from this point forward, we will be heavily relying on calculators for the rest of the course. Okay? So make sure you have them. It's going to make your life easier. It's also going to boost up those test scores, your ACT and SAT, where you can use those calculators. It's really going to help you when you know how to use them.
So pretty much.
My Y, hold on. My Y, I'm taking from 5 to 10. So on your homework, every problem is going to look like this. You're going to write the equation down. You're going to tell me the constant, the leading coefficient, the type, and the y-intercept. Then you're going to sketch the graph, and you're going to tell me what window you used when you graphed it.
Can I take a picture of that? I'll figure it out.
Okay?
What? So I'm gonna get a calculator this week if I don't.
Tell me the type. Quartic?
Oh yeah, just
Leading coefficient?
1.
Degree?
4.
4. Y-intercept?
4.
Let's graph it.
Ooh.
Sketch it and give me the window you use. Y'all try this one. Let me record this. x to the fourth, x to the fourth minus x to the third minus 4x squared plus 4. I'm going to start out with a zoom 6 because that's a 10 by 10. It's actually not a bad window as it sits right now. You could actually use that window okay. If you want to do some adjusting, I would shave off some on both sides of the x's. Maybe take the x from -5 to 5. And maybe shave a little bit off the bottom. So maybe make the y min -7.
-5.
Does it still show everything?
Yeah.
Okay.
I did -2, +3, and -5.
That's fine. That's fine. So now for mine, everybody's is going to be a little bit different. If you have the same thing, guys, if y'all could pay attention, that would be great. Thank you. If you turn in the exact same thing as somebody else's, then you copied theirs. There's no way everybody's going to have the exact same window every single time. We just did it together, and 2 or 3 of y'all had a different window than I had. It's however you adjust to see your picture. Understand everything you're looking for, though, okay? I know Cortex are going to have those 2 bumps on them. I know a cubic. I know its general form. I know every time I go up one on the exponent, it's going to add another hump, okay? So I need to make sure I've adjusted so that I see all that. Some of them you may grab and you don't see it in the initial window and you don't have to shave anything off, but you have to increase it to see more.
Yeah, I had to because I had stuff on the last.
You were still in the same setting, right? And that's fine if you do that, or you can reset to a standard window to -10 to 10. Yes, Robert.
Window, do we just write what we have in?
Right.